Welcome to the submodule Water for Urban Development. My name is Marie-Claire ten Veldhuis. I work as an assistant professor for urban water systems at Delft University of Technology. Now, people, of course, need water to live and survive. In urban areas, large numbers of people are living together in high concentrations, and they need a lot of water. How do citizens get access to sufficient volumes of water? Where do cities get their water supply from? Are cities suffering from water stress, or are waters suffering from urbanization? In this submodule, we will have a look at how cities and water systems interact. Since 2010, more than 50% of the world population is living in cities, and this number is expected to rise in the next decades. So cities face the challenge of meeting water demands of their growing populations. Now, how much water does a city actually need? A good starting point to estimate urban water needs is to multiply the urban population by the average daily water use per person. This is also referred to as the per capita water use. Water use patterns vary a lot between countries, regions, even within cities, depending on access to drinking water, availability and costs. For instance, in Mumbai, India, per capita water use is 15 times higher in high-income suburbs with good water access compared to slum areas. Worldwide, average water use per person varies from less than 50 liters per day to over 500 liters per day. These numbers include direct consumption of water, bathing and showering, water usage for washing clothes and dishes, and garden watering. Now let's have a look at two different cities and estimate how much water is used by their citizens. Rotterdam is the second largest city in the Netherlands, located in the Rhine Delta at the North Sea coast. Jakarta is the capital of Indonesia, located in the delta of the Citarum and several other rivers. Now, Rotterdam is a modern industrial city with a large port area, and Jakarta is a rapidly growing metropolis with large variations in economic development between the city's neighborhoods. Now, let's make an estimate of domestic water use for these two cities and answer the following questions. How large is the urban population of Jakarta and Rotterdam? What is the average domestic water use? What is the total water need of the city's population? What is the main source of domestic water use for the urban population? First, we'll fill in some numbers for general characteristics of the cities of Rotterdam and Jakarta. Total population, size of the city area, population density, and average domestic water use. From these numbers, we can compute average daily water use and total yearly water use. Now, to get a grasp of these numbers, 1 million cubic meter of water is about the equivalent in volume of 250 Olympic swimming pools. These volumes of water need to be made available in the city or need to be transported there if not available locally. Let's look at some potential sources of water for Rotterdam and Jakarta and see how they compare to the daily and yearly domestic water use estimates that we just found. Now, a first option is using rainfall that directly falls on the city's surface. Jakarta, located in the tropics, receives a lot of rainfall. On average, 1,850 millimeters yearly. Rotterdam, with a moderate climate, gets less rainfall, about 850 millimeters. If we multiply this by the city's surface area, we'll find the total yearly available amount of rainwater. Now, as we can see by comparing the numbers, there is more than enough rainwater to cover the city's water needs on an annual basis. That is, if we would be able to capture all rainwater, and if rainfall would be spread nicely and evenly over all days of the year. Now, another potential source of water, as we saw in a previous submodule, is groundwater. Available groundwater resources depend on natural replenishment by rainfall, the size of the groundwater basin, and the thickness of the ground layers that groundwater can be pumped from. And it depends on the quality too. Groundwater near the sea turns saline as a result of salt intrusion and therefore is not suitable for most water uses. This is why groundwater in the Rotterdam region is not used for consumption. In Jakarta, estimates of groundwater availability and use vary as there are many private abstractions on top of the larger abstractions for industry and drinking water production. It is estimated that about 60 million cubic meters of groundwater is abstracted annually for Jakarta's water supply. This is by no means sufficient to meet the total water needs. River water is an obvious third source of water, especially in delta cities like Jakarta and Rotterdam. Rivers in both cities transport water from large upstream catchments. In Rotterdam, the Rhine and Meuse rivers transport approximately 80 billion cubic meters annually. And in Jakarta, about 6 billion cubic meters of water flow through Citarum rivers on average. This is more than enough to cover urban water needs. But like rainfall, river flows are not equally distributed over the year, so intermediate storage is needed to cover periods of low flow. Now, what can we conclude from these numbers? First, that in Jakarta and Rotterdam, annual rainfall is in principle sufficient to cover the city's water needs. Groundwater availability is limited and cannot on its own cover total water needs. River water is the largest source of water for the two delta cities, yet most of this water comes from large upstream catchments. And here, the city is competing with many other water demands, especially from agriculture. Domestic water use is small compared to water use by other sectors. Globally, domestic water use represents about 5 to 10%, while industry about 15%, and agriculture up to 80% of total water use. Again, these figures vary widely from region to region, depending on agricultural and industrial activities and water availability. In Northwestern Europe, for instance, agriculture represents less than 16% of total water use, and more than half is used by industry. In most tropical regions, agriculture is the main water-using sector by far, representing up to almost 100% of total water use. Now back to our two cities. What water resources are they using to cover domestic water needs? In Jakarta and Rotterdam, river water is the main source used to cover urban water needs. Now, because river flows are fluctuating between wet and dry periods, large reservoirs have been constructed in both cases to store water and overcome periods of low flow. In Jakarta, river water is supplemented with groundwater abstracted from a few large wells and a lot of individual small wells at household level. An important reason for construction of these wells is the insecurity of Jakarta's central water supply. Now, interestingly, rainfall, a large source of locally available water in both cities, is not used by the city's households. This applies to most cities worldwide. Very few cities are using rainwater as a water resource. Now, the question remains, why are cities not using clean, locally available rainfall to cover their water needs? Part of the explanation is to be found in historical development. The following images illustrate how cities, as they grow, take in water from an increasingly large part of their surroundings. They start using groundwater, as this is a more or less constant, locally available source of water. Now, gradually, local groundwater resources get contaminated and may even get depleted. This means water needs to be taken elsewhere and transported to the city. Groundwater is abstracted from the surrounding region, and when this is no longer sufficient, river water is used as a supplement. This means constructing large dams to create reservoirs and store water to overcome periods of low river flow. Somehow, in this process, rainwater seems to be forgotten as a potential, locally available resource. In large cities worldwide, some 1.2 billion people primarily depend on river water sources. The remainder, about 20% of the urban population, depends mainly on groundwater. While groundwater is mostly drawn from within or close to the city boundaries, river water is taken from much larger catchment areas. Urban areas cover about 2 to 4% of the Earth's land surface. Now, upstream areas used for their water sources, their urban water footprints, cover more than 40% of the Earth's surface. So worldwide, the urban water footprint is about 10 times the size of the actual cities. Bringing large volumes of water to the cities from such extensive areas requires a lot of water infrastructure. It's estimated that globally cities transport more than 500 billion liters of water daily over a total distance of 27,000 kilometers. When laid in a straight line, urban water infrastructure could stretch halfway around the globe. Even so, many large cities are under water stress and can't always supply their citizens and economic activities with sufficient water. As cities continue to grow, new solutions will have to be found to meet urban water needs. Rainwater harvesting and water reuse are examples of new developments that will help to quench cities' thirst in a more sustainable way in the future.